Satellite traffic is supposed to get 10 to 100 times busier over the next decade. How can we make it safer? Find out in today's episode.
3, 2, 1. Engine full power.
Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Hello, thanks so much for joining me for Your Space Journey. My name is Chuck. Today we're going to talk to the company Vyoma about how they're changing the way space debris is monitored. Today we speak with Dr. Luisa Buinhas of Vyoma, a company revolutionizing the way space debris is monitored and managed. Luisa has a background in space situational awareness and debris management, and her company offers a range of technology and services to help organizations track and mitigate the effects of space debris. With the increasing use of satellites and the potential risk posed by debris in orbit, Vyoma services are more important than ever. In this interview, we'll be discussing how Vyoma's technology works, the challenges the company faces, and how it is working towards a more sustainable future for space activities.
Your Space Journey.
Luisa, thank you so much for joining me today. Really appreciate it.
Thank you. It's a pleasure to talk to you today. I'm very curious to hear what we have to discuss.
Well, I'm curious to hear about you and your amazing company, Vyoma. For one, I wanted to talk about your background a little bit because I understand you have a doctorate. Aerospace engineering is a field you went into, specializing in space mission design and maneuver optimization. I think that's fascinating. What drew you to that field, if I can ask?
Well, to be honest, I never thought that I would end up in aerospace engineering. So I
Oh,
always
really?
thought that I would end up doing something with medicine or like the human body, like biomedical engineering, for example. But it was really one random afternoon that I turned on the TV and I saw that there was a program on Discovery Channel about the International Space Station that I realized that, oh my God, this is actually quite an interesting field. How come I never considered it? And by that time, I had already applied to university, so I had to go back and change my application. So this random afternoon show on Discovery Channel really turned everything upside down that day, and this is how I actually got into aerospace engineering.
I think,
And
wow. No, I think that's amazing. I mean, because again, going from medicine to aerospace engineering, and you've certainly been sort of a trendsetter in that. And I really kind of love how your passion comes through about space situational awareness and how Vyoma is working to attack that. Can you tell us just in a general sense? I know it's common sense, but why is space situational awareness important?
Right. So, space situational awareness actually encompasses information about our orbital environment. It was always important in the sense that it's part of a mission to track exactly what we send up there. So, but it really only got kind of more and more important lately as congestion became an issue in our orbits. So, as we launch more and more objects into space that stay there for decades, and depending on the orbits, they actually stay there for thousands of years. There has to be a proper approach to managing all of this traffic. And for us to be able to manage space traffic, we need to know and understand where exactly traffic is, where the objects are, where they are predicted to be in the next day, in the next few days, such that we can plan any avoidance maneuvers way ahead of time and avoid any dangerous situations like close approaches. So space situational awareness has always been part of, let's say, the institutional activities of institutional entities like NASA and ESA, but it's really nowadays with the commercial players coming into the forefront of space activities that it's really gaining relevance because we need really to understand who the stakeholders are in space and where the objects that they own are also located, where they will be, and etc.
See, I think that's amazing. And I think you had mentioned before there's like 130 million pieces at least out there, and we only see about 10 to 12% of those. So it's obviously a very fascinating field and something we have to work hard to make it safe. You had a great TED Talk, I think just last year, where you spoke about 4 initiatives: disposal, maintenance, safety, and IT. I'd love to go into these kind of at a high level just a bit, starting with disposal. Can you tell us more about the plans to remove those non-working satellites or other debris?
Right. So there are several ways that you can dispose of a satellite at the end of a lifetime. So typically, disposal has revolved around satellites maneuvering by themselves out of the orbit, either through propulsion systems or by using drag mechanisms, so increasing the drag such that they will slowly deorbit back to Earth. But one of the few, let's say, initiatives that is, being studied at institutional level is really trying to do something with the satellites that are there. So the space objects that are still in orbit and by themselves cannot be removed from space. And so this is an area which is called active debris removal. So there are certain initiatives that now start thinking a little bit into the future in approaching these dead objects, grasping them, manipulating them, and then bringing them down to the atmosphere in order for them to burn up, or actually removing these objects by pulling them into what we call graveyard orbits. So really high orbits that just pretty much clear the debris, clear these dead satellites and objects out of the way of active satellites. So these are some, let's say, some of the thought processes behind active debris removal.
And that's fascinating. And another aspect, of course, in addition to removal of the debris, is the maintenance. The second initiative that deals with fixing those aging satellites. Can you tell us a little bit more about that?
Right. So maintenance really is aimed at prolonging the lifetime of satellites. And you can do this, for instance, by swapping parts of a satellite that is malfunctioning. For instance, solar arrays, you know that, for example, solar cells, they lose efficiency as they go on, as they go through time, let's say. So instead of really stopping the satellite, if everything else in an active satellite is working except part, in this case, solar cells, we could just simply swap these defunct parts with new parts and kind of upgrade these satellites in order to allow them to operate further. So we're really extending the useful life of satellites. And the good thing about it is that satellites are becoming really more and more modular, so less interconnected in terms of components in themselves. So hopefully this will also make, let's say, this maintenance part a little bit easier in the future. One of the critical aspects that needs to be tackled, of course, is the issue of standards and interfaces, because there are so many different manufacturers of spacecraft, of CubeSats, and so on. So each of them uses their own system. So before being able to do maintenance, let's say on a really large scale, there has to be a technical harmonization on the standard side, on the interfaces, such that it makes it a lot easier to grasp and to grapple these space objects in orbit.
See, and that, I guess standards is kind of a good thing. It kind of reminds me of your next initiative is safety. Is that dealing with regulations and kind of the rules and the standards for that? What is safety as far as that goes?
Well, safety is a very broad concept that involves, let's say, many aspects of space traffic. One of the things that needs to be identified very early on is who the stakeholders are, what are their interests, and what would actually get them to come to the table and start talking to the other stakeholders in order to come to a common understanding of what the status of our orbits is. That's number one. And number two, what could we do together about it in order to avoid and mitigate future problems? So mitigate the generation of future debris. And thirdly, actually, what could we do together actually to tackle space sustainability right now? So, for instance, it's about perhaps agreeing on certain pieces of information that could be shared, such as, for example, when these satellites will pass at a certain congested point in the orbit, and in case there's a close approach, who maneuvers. And I think this is more or less, let's say, agreeable that if you're talking about research and publicly funded satellites, that somehow they could have the right of way. But when we're talking about two, let's say, commercial entities, two industrial stakeholders, they need to decide who maneuvers out of the way if there's a close approach. And of course, this also needs that you need to bring into the table information about the status of your satellite in terms of health. So how feasible it is that your satellite will survive this maneuver and how much that jeopardizes the lifetime of your satellite in case you are the one maneuvering. So all of this information, this needs to be, there needs to be a basis for people to agree on, such that we avoid having over congested orbits in the future.
One of the other things that fascinates me, I'm in the information technology field, and one thing you said, common sense, I guess, is just how much data that we're getting from these satellites on a daily basis and how it can be overwhelming and sort of congest the network. You have a solution of creating basically a network of data centers. Can you tell us more about that solution?
Yes. So what we do at Vyoma is we work with the observation of space objects. Currently, we do it from the ground, but from the middle of next year, we will have our own first pilot satellites in orbit to monitor and track space debris. Now, we have, let's say, a couple of operational modes on our satellites. So for instance, one of the things that we allow is to have customers logging into our platform, booking our sensors, so our sensors that will be in space, and make any requests for observation data, such as images or even data products that come out, let's say, of the images that we record. Now, in these cases, for instance, when we get requests for data, it is important to us that we get this data down to the customer as fast as possible. So in this sense, we do have, let's say, a latency importance in terms of how fast we can provide this data to the customer. Now, this goes a little bit in the direction of what you mentioned about using networks of computers in space or networks of communication satellites in space in order to make latencies of data transmission as short as possible. One of the solutions that we explore, for instance, is the reduction of data on board. So we are continuously generating data in space, and we really try to compress 99 to up to 99% of the data that we generate through a process which is called segmentation and compression. And this means that whatever gets downlinked to the ground is only a fraction of the original size. And this means that we don't need to have large, let's say, we don't have bottlenecks in terms of data transmission. So we have only short packages of data to transmit. And we could explore, for example, either doing it directly with ground networks or making use of communication relay satellites. So you see now the constellations of satellites that are currently being deployed in orbit, and they are typically used to service ground. So they are service the people on the ground. But there has been a shift recently in which you have other companies from America and from Canada that are using their satellites to service other satellites. So actually, when we're trying to reduce latencies, is making use of these communication satellites in orbit that support other satellites in transmitting data to the ground as fast as possible. So this is what we're say dealing with when we're talking about data transmission and reducing the latencies of data to the ground.
Well, your company, you have so many unique initiatives, which I love. And one of the fascinating aspects I found is your constellation, where you're using actually in orbit telescopes to observe space objects. Tell us more about that. That's fascinating.
Yes, I mean, this is really an attempt, let's say, to fill an information gap that exists nowadays. That's number one, in terms of object classes, object sizes. And number two, being able to generate information that is real time or very close to real time when it comes to mapping the space environments. So really augmenting space situational awareness, if you will. So by observing, let's take a step back first and let's understand a little bit how it is done nowadays, the observation of these space objects. So it's on the basis of ground telescopes and radars primarily. But for instance, ground telescopes, they suffer from weather effects. So whenever there's clouds or dust, these telescopes cannot be used and they typically observe at nighttime because this is when you have a dark sky with bright objects passing over it. So this means that most of the times these ground-based space telescopes are really not generating any information because they cannot make observations. By going into space, we are really bypassing any weather effects, and this allows us to observe 24/7. So this is one of the main advantages of going into space for observing space objects. And if you look to radars, typically radars, so the power that is required to put into a radar, it decreases with the square of the distance. So if you need to send a signal up to detect an object and then retrieve the signal back down to Earth, you're talking about the power of 4. So you're losing a lot of power with radars. And this means that radars are very good at observing or detecting objects, but very low flying objects. So very low altitude objects in space. And what we're really trying to address is all the higher altitudes still in low orbit, so 600 kilometers, 500 kilometers and above, in really detecting these objects that currently we know that are out there, but we just don't really know where. And at the same time, observe new objects that are too small or too faint to be detected from the ground. So this is really the idea of going into space. And of course, by having a constellation of satellites, this allows us to reduce latencies to just a few minutes. So we're actually providing really updated information about the positions and velocities and trajectories of all of these space objects, satellites, and debris in real time, very close to real time.
Wow, that's amazing. And again, I think that's totally unique. An approach that I haven't seen any other company use. And one other approach that I find fascinating that you're using is using AI, artificial intelligence, machine learning for safe and automated satellite operations. Can you tell us just big picture of how that works?
Right. So we're using machine learning and computer vision pretty much in the image processing pipeline. So this is really the core of the IP of our development. So this is kind of part of our secret sauce. But really, it boils down into trying to make the right, first of all, identifications in an image about what is an object and what is a star. And once we have this in place, this accurate detection and differentiation between objects and stars, we go back into the catalog. So the catalog where we know all the objects that are out there, and trying to do this association between what we have just observed and what is in the catalog. And if after a set of observations, we realize that we're looking at an object that is not yet cataloged before, then we make a new entry in the catalog. This uses, let's say, the image processing classification part. This is something that is uses a mixture of machine learning and computer vision on the one hand, but also classical astrodynamics algorithms, because you need to be able to predict, let's say, where the object will be in the future in order to be able to say, okay, so this object that we observed, a few hours ago, and then we think that we just observed it. Is it the right object? Is it not? Where did we expect this object to be? So by fusing, let's say, these two streams, so astrodynamics and machine learning and computer vision, we bring these two together to go through our image processing pipeline and the cataloging of objects.
That is incredible. Now, I thought you mentioned earlier that you might be launching some of your satellites next year, whatever. Can you tell us what is next? What is next for you and Vyoma?
Right, that's an excellent question. So the launch of our satellites is due for the middle of 2024. We have a set of intermediary milestones until then. So we're currently closing phase B of our mission, and we will start the phase C very soon. This really is going into the detailed design of our satellites, and early next year we will have the integration of our telescopes into the spacecraft, so into the satellites themselves, before going into the last battery of tests of the satellites to make sure that they're properly functional for launch in the middle of next year. So that's a big milestone. And at the same time, we're already working with the second generation satellites that will come after that. So we're doing the conceptual study for the second generation telescopes and the second generation satellite mission together with some of our partners. And we hope to start working on launching the second generation constellation in 2025 and 2026.
Luisa, how do you go from observing in space to providing your services?
That is an excellent question. So really the data that is generated feeds into our, let's say, space safety platform. We currently provide observations of space debris, as I mentioned, from the ground with our ground-based telescopes network, but in the future from space. So the images that we collect will be turned into useful data products and orbit determination for our customers. Now, at the same time, we also provide collision avoidance, and this is from the detection of close approaches between the satellites of our customers and other objects, either other satellites or space debris. And if there is a close approach, we calculate the probability of a collision. And whenever there is a high risk probability, we also provide the maneuver that could be executed by the customer. So this means that we cover, let's say, all the spectrum of collision avoidance and maneuvering. We do the planning for the customer, and then based on the characteristics of the satellite of the customer, so for instance, the remaining power availability, for instance, eclipse conditions, in case there are forbidden directions of maneuvering, we also take this into account. And then we do the screening of this maneuver. So it's not only providing a collision avoidance maneuver relative to an existing satellite, it's making sure that whenever you're providing an evasive solution, an evasive maneuver, that you're not going to collide subsequently with other objects. So doing this study with each maneuver that is planned is something that we afford to the customers. And the customers can seemingly just log into our platform, um, put in the data of their satellites, upload ephemeris files, for instance, and they can, let's say, very visually observe the geometry of the close approach, what we call the geometry of the conjunction, and then play with parameters in the maneuver that we suggest, and make the best informed decision based on their own interests, and then execute the maneuver. So this is very much how we transform data into services.
See, I think that's fascinating. I was just thinking when you're saying that, you have some great visuals on your site. I want to encourage our audience to go to vyoma.space. You have some visualizations that show that. I think that's fascinating. Another question that just came to mind too is doing all these fascinating services and accomplishing these amazing goals. As a startup company, you've had to face some amazing challenges. What are the biggest challenges you've faced so far?
That's also a very good question. So I can tell you that perhaps one of the big challenges that we face early on and still face nowadays is being very ambitious in terms of the goals, without having all the human resources in place to achieve everything that we wanted. So this was a learning at the beginning for us, trying to be a little bit more realistic in terms of the milestones that we could achieve. But we've also grown the team. So we're currently 19 people in total. And that's an amazing expansion. We have an amazing technical team that really supports us in achieving, let's say, really materializing and concretizing our vision. But indeed, in early stages, this was a very big learning for us. And I can tell you perhaps that as a second challenge that we faced is that space is dominated by very traditional players, let's say, traditional institutions. So it's difficult as a young company, especially in Europe, because I think in Europe we are very risk averse in trying to propose solutions that are a bit out of the box with space-based observations and so on. I think we've fostered a lot of very good connections over the past 3 years. So I think we're on a good track. But indeed, one of the challenges is that we face was how conservative our industry is. And of course, being taken seriously in institutional media about the solutions and the disruption of the solutions that we bring in.
That is so exciting. Luisa, we're just so excited for you and for Vyoma. Just want to commend your company on just so far how you've come and what you have planned for the future. I think it's going to be great for all of humanity. So I want to thank you for taking time out of your busy schedule to join us today. Thank you so much.
Thank you very much, Chuck. It was a pleasure to talk to you today.
Your space journey.
Well, I really enjoyed my conversation with Luisa today, and I'm fascinated with the efforts of Vyoma. If you'd like to learn more about their company, just go to their website at vyoma.space. I want to thank Luisa for joining me today. I want to thank you for joining us as well. Again, if you could do me a small favor and share this episode with a friend, I'd certainly appreciate it. Thanks so much for joining us. We'll see you next time. God bless.